Hi, my name is Dana Golden. Today we're going to talk about two different tools you can use to analyze LCOE and LACE. So two different tools you can use to think about costs and cost-benefit analysis in the electricity market. One is CREST. CREST is the cost of renewable energy spreadsheet tool. It's a free modeling tool put up by the National Renewable Energy Laboratory out in Golden, Colorado. These people do great work. Yeah, I hope they hire me one day. I look forward to moving to Golden, more than willing to. I love them. It's designed to evaluate the economic feasibility of renewable energy projects, including wind, solar, and geothermal. It's an Excel-based tool that allows users to assess the impact of key financial and policy parameters on project economics. So it allows you to calculate levelized cost of energy, models cash flows, tax credits, and depreciation, and you can tailor it to specific renewable energy technologies. It's designed to be used by policymakers, project developers, and analysts. So it supports solar PV and solar thermal. You can also use it for fuel cells, both offshore and onshore wind, and then you can use it for biomass and geothermal. So using the CREST tool, first you have to download it from the NREL's website. Make sure that macros are enabled in Excel, and make sure you're using the right spreadsheets for the energy technology you're looking at. Input the project parameters, specify the technology type, solar, PV, wind, because that's the spreadsheet you're going to want, and then enter the system size, capacity, factor, and project lifetime, the different variables that you're going to use in your analysis, and then provide some detailed financial inputs such as capital costs, O&M, and financing structure. You can provide more detailed inputs if you want, and then you can also look at policy and incentive information. Maybe if you're a policymaker and you want to know how this is affecting the average generator in your market, so you can add some tax credits, some grants, and some renewable energy credits. And then if you want to, you can model a different depreciation schedule. Maybe you want to change the depreciation schedule to see what's happening. I didn't do a lot of this. I don't do a lot of this. I mainly am changing technical variables or policy parameters, but I'm sure someone out there is an engineer who loves tax analysis, who's like, I spend all day changing the depreciation schedule in CREST. And if that's you, I'm very happy for you. So, analyzing results, you review the LCOE, the cash flow projections, and the return on investment. And then you perform some sensitivity analysis by adjusting key variables like the interest rate, like the net capacity factor, like the total capacity amount. So you can see the LCOE breakdown, how factors contribute to LCOE, and you can change your assumptions to see how they affect LCOE. And then you can look at some graphs and tables as well as cash flows. Then we have SLOPE, which is the State and Local Planning for Energy tool, which is an integrated, free, and publicly available online platform developed by NREL, the National Renewable Energy Laboratory. It's designed to support state and local decision makers in energy planning and policy development, and provides data analysis on energy efficiency, renewable energy, and sustainable transportation options. So you can see what they're seeing happen, what are the energy scenarios that they're seeing play out. They take data from the DOE and EPA on these energy scenarios. The DOE, of course, publishes. Actually, NREL is a part of the DOE, so this is really being taken from EIA, the Energy Information Administration. They publish the Annual Energy Outlook, which provides long-term planning. They use that long-term planning for scenario modeling to show what technology is going to become more cost-effective over time, as it allows for comparison of energy opportunities at the state, county, and city levels. So using the SLOPE tool, first access the tool, visit the SLOPE platform on NREL's website. There's no installation required. It's entirely web-based. Then explore the data. Choose a geographic area, state, county, or city. Browse the data layers such as renewable energy potential, energy consumption cost, and then create some scenarios. Look at how different policy variables impact energy efficiency and the viability of projects. And then analyze the results. Use some charts and maps showing how energy use, emissions reductions, and costs differ across space and time. And then look at how these different scenarios, and then you can export the data and charts to Excel or to whatever you're using for your presentation to whoever you're showing this to. And can you use the results of proposal and grant applications to showcase how the policy affects different things. This is useful in strategic energy planning, evaluating renewable energy investment potential, and supporting decarbonization emissions. This allows you to see what is the most economical electricity source at different places. So here you can see the cost of energy and the levelized cost of energy. In most of the country, combined cycle natural gas is the cheapest, and in some places, it's land-based wind is the cheapest right now. Hydropower is cheap, but so are wind and solar. I took off hydropower here because if I added hydropower, everything would have been hydropower because hydropower is extraordinarily cheap. You can't put in much more of it. But yeah, so this is how you can visualize across space. Finally today, and then I'll have another couple videos because in your homework, I want you to use slope and I want you to use CREST. I'll have a couple of videos introducing you to the tools. But finally today, I will talk about the envirotech industry. A lot of firms are starting to think about their emissions and environmental impact, and so they're hiring people to think about this. A lot of them do environmental cleanup, and so a lot of them hire consultants or full-time employees to help implement new pollution control and practices and technologies. Some of them have even a role of chief sustainability officer to think about how to think about environmental trends in this case. They really want people who can help them lower marginal abatement costs and figure out a way to deal with the environmental costs but do it cheaply. This is probably a huge employer for the kind of people who are in this room taking this sort of class. And if you're interested, I can help you start to look into these sorts of jobs. And I hope you have a great day. Have fun with CREST and slope on the homework. Thank you, Dana.